Hello everyone, welcome to this video about covalent bonding. So in our last session we talked about ionic bonding and how the aim of these elements, of every element, was to get a full outer shell so it looked like the noble gases. So remember, every element wants to end up looking like a noble gas. And at the end of that video, I posed a question about carbon. Carbon's kind of in a tricky spot because if it was going to get a full outer shell by gaining or losing electrons, it would have to gain or lose 4. Now that is really too many. There isn't really any energetic plus to either gaining or losing 4 electrons. This is where covalent bonding comes in. Now, covalent bonding is pretty much restricted to this top right-hand corner of the periodic table and hydrogen. Now, these guys are, let me just switch my pen, non-metals. Now, if we're only looking at like less than a third of the elements in the periodic table, why do we care so much about covalent bonding? Why am I sitting here talking about it? That's because these elements here that I've highlighted, especially carbon, hydrogen, oxygen, nitrogen, and sulfur, if you take those elements, those are the key elements for biochemistry, so the chemistry of living things. So most of the chemistry that's going on, for example, in my digestive system now as it breaks down my lunch, that is all based around covalent bonding between these elements. So covalent bonding still follows, covalent bonding still follows that octet rule/guideline that I discussed in the ionic video. But let's break down what this word means. Co, in the same way that we use this prefix for cooperation, etc. Co means with or maybe sharing. And valent comes from the word valence, which is the outside shell of electrons. So, for example, if we look at carbon, so carbon has 6 protons and 6 electrons. So in its inner shell, it's got 2 electrons, and its outer shell, it's got 4. So for covalent bonding, we're talking about the bonding that happens in this outside electron shell. So, as was previously shown, another way we can show carbon is like this, with dots to represent those different electrons. So, carbon wants 8 electrons in its outer shell. Remember that octet guideline that we talked about. So, for example, it can share this electron with a hydrogen, this electron with a hydrogen, this electron with a hydrogen, and this electron with a hydrogen. My carbon, oh, sorry, that's not terribly clear. My carbon now has 2, 4, 6, 8 electrons. So my carbon has that octet. But each of my hydrogens, remember hydrogen is on that next shell in. So each of these hydrogens now have access to those 2 electrons. This way of showing electrons with dots is called a Lewis structure. And it's just a really simple way for us to see what's going on in the outer shells of these atoms. So this bond that's here is formed by 1 electron from my hydrogen and 1 electron from my carbon. So they are sharing, so that is our covalent bond. It's a really simple way for us to show how these things are connected. So you can show it with 2 colours, like I've just done there. You can also show it using, this is called a dot and cross. So I show my carbon electrons as being dots and my hydrogen electrons as being crosses. So this is called a dot and cross. Another way we can show it is by using lines. So for a pair of electrons that's shared, we can replace it with a line. So this is a form that you might be familiar with. All of these diagrams are showing the exact same molecule, which in this case is methane. Let's do a slightly more complex molecule, which is C2H6, which is called, oh, I didn't mean to draw up then, which is called ethane. So for this, I've got my 2 carbon atoms in the middle. And then hydrogens. And I'm going to draw dots, dot and cross. This is a completely acceptable way of showing molecules all the way up to like IB chemistry, like DP chemistry. This is a completely acceptable way of showing it. Here, I have 2 electrons that are being shared. So this is called a single bond. So in a single bond, there are 2 shared electrons. Let's move across to a relative of ethane called ethene. Now this one you might find a bit trickier to draw. That's cool. Let's start by joining our 2 carbons in the middle. But I've only got 4 hydrogens. So let's say, okay, oh, sorry, I meant to draw that as a cross. Let's say, okay, each of those carbons should have 2 hydrogens attached. But these carbons now have 1 electron each left over. What if, instead of just sharing 1 pair of electrons, my carbon atoms were able to share 2 pairs of electrons? Let me just change colour. So I have 2 pairs of electrons that are being shared. So this is called a double bond. So I can have 1 pair of electrons being shared, which is a single bond. I can have 2 pairs of electrons that are being shared, which is a double bond. Hopefully you can see the pattern I'm going for here when I draw. This is ethine, which has 3 shared pairs of electrons. So let me just get my highlighter out. This one. So here I have 3 shared electron pairs, which is a triple bond. Now, I cannot have a quadruple bond. Think about electrons in a similar way to how you think about magnets. When you try and put 2 north ends together, they repel. Same thing happens with my electrons. Remember, those electrons have negative charges, and that means that they repel each other. So if I try and cram a 4th pair of electrons in between those 2 atoms, there's too much repulsion and they pop apart. So, for those of you who are paying attention, there is a similarity between these names. That is something that we will get into more detail in if you do year 11 and 12 chemistry. The key point for us to know today is that non-metals are the ones that do covalent bonding. So the ones in this top right-hand corner of the periodic table, plus hydrogen. The main reason that it's important is because they show up, these covalent bonds show up all the time, all over nature. It isn't just ionic bonding that occurs in nature. And the covalent bonding, the aim is still that octet, but we get it by sharing electrons rather than stealing or donating them. So, and this is how you can draw those. Okay, I have also given you access to a worksheet which will give you some more practice of these. It is really helpful for anybody who's going to study chemistry or biology next year to be able to understand how these atoms fit together. So please have a go at that worksheet. I believe I have set that to be due later in the week. Please let me know if you've got any questions. I had some trouble with a video that I put up a couple of days back with people, nobody we know, leaving like porn spam links in the comments. So I'm going to be turning off comments for my videos from now on. Please let me know if you have any questions though. Okay, thank you so much. Have a fantastic rest of your day and I shall see you next time. Bye.